Hello, this is Geometry 9.2. We'll be talking about special right triangles. And one of the special right triangles that we'll be talking about is a 45-45-90 triangle, or it could also be referred to as an isosceles right triangle. So in your 45-45-90 triangle, for our right triangles that are our special right triangles, one thing to keep in mind is all 45-45-90 triangles are similar, specifically by the angle-angle similarity theorem. That means all the sides are in proportion. But what the 45-45-90 triangle theorem states is the hypotenuse is square root times as long as each of the legs. So each of the legs would always be congruent. That's why it's an isosceles right triangle. And if each of the legs are just x, then the hypotenuse would be x times the square root of 2. Or sometimes we just use a baseline number like 1. These two angles are congruent here. That means they're each 45 degrees. If each of the legs are 1, then the hypotenuse would be 1 times the square root of 2. That's the 45-45-90 triangle theorem. So there's the 45-45-90 triangle theorem written out in words. And then before we go over the next special right triangle, there'll be 2 special right triangles and all. I do want to go over some examples. So you could use either this with just generic or variable side lengths for each of the legs, or you could use this where you have 1 for the side lengths of legs to figure out missing side lengths for a 45-45-90 triangle. So I want to find the missing value here. I have a 45-45-90 triangle. Be aware that it could be given like this, like I have it here. Each of the angles could also be given as 45 degrees, or just one of the angles besides the right angle could be 45 degrees. Okay. Let's just say I'm given this. One of the legs is 15. You want to find the length of the hypotenuse. So you could use the fact that the hypotenuse is square root times 2, longer than each of the legs. So this leg is 15, then x would be 15 times the square root of 2. You just leave it like that. That's in simplified radical form. Another way that you could set it up is to use this, what I call the baseline triangle, because I could set up proportions. These two 45-45-90 triangles or isosceles right triangles are similar. What that means is the sides should be in proportion. So a proportion that you could set up is 15 over 1. Those two sides correspond, would have to equal. Notice I have a side in this triangle over the baseline triangle. So x has to go in the numerator over 1 times the square root of 2, or just the square root of 2. Then to solve this for x, I can cross multiply 15 times the square root of 2 and then divide it by 1. You get the exact same thing. So in my opinion, when you're solving or finding missing side lengths of a 45-45-90 triangle, it's easiest if you're given the one of the legs or even both of the legs. Even though we only wanted to find x here, this side would be 15. Then to find the hypotenuse, you multiply by the square root of 2. It's actually not that much more difficult if you're given the hypotenuse. So let's just say now that I want to find the length of one of the legs for this 45-45-90 triangle. If we're given one of the legs and we want to find the hypotenuse, we multiply by the square root of 2. Now we're given the hypotenuse and want to find either one or both of the legs. So just do the opposite. Divide by the square root of 2. X equals 9 divided by the square root of 2. Okay, but we need to refer back to algebra because we can't leave our radical in the denominator. So we need to do what's called rationalizing the denominator. I need to simplify this radical expression. We need to get the square root of 2 out of the denominator. In order to rationalize, we multiply both the numerator and denominator by the radical in the denominator, in this case, the square root of 2. In the numerator, 9 times the square root of 2, it's just 9 root 2. I can't multiply the 9 and 2 because the 2 is underneath the radical, 9 is not. Square root of 2 times the square root of 2, it's the square root of 4, but if you take the square root of 4, that's just 2. So this would be the length of each of the legs. That's one way that you can find the length of each of the legs. First, divide by the square root of 2, and then rationalize the denominator. Or, let me show you or tell you a bit of a shortcut. Instead of doing both those parts, maybe some of you realize, well, can't I just multiply by square root 2 over 2? Yes. So that's how else you can find the hypotenuse. And then another way to be able to find the hypotenuse is I could use this, what I refer to as the baseline triangle. I could set up a proportion, x over 9. You could also set up 9 over x. It actually doesn't matter. x over 9. If I set it up like that, then what corresponds with x is 1. And then what corresponds with 9 is, I wrote up here 1 times the square root of 2. That's the same as the square root of 2. I still cross multiply. 9 times 1 is 9. Then divide by the square root of 2. Here's what we end up with. And then we would still need to get rid of the radical in the denominator, or again, that's called rationalizing the denominator. You multiply by the square root of 2 over the square root of 2. You end up with 9 root 2 over 2.